I've got a conducting piece of metal, and I'm pulling it across a magnetic field. Okay? Let's start with this idea. It's moving. Okay? The metal is moving across this magnetic field. So, we're going to use the right-hand rule. So, we're going to assume that we're talking about the positive charges inside the piece of metal. So, we're going this way. The magnetic field is going into the page. Which direction do your fingers point? Up. So, what that means is that the top part of this is going to become positively charged, and the bottom part is going to become negatively charged. So if I do that, what's going to be the direction of the electric field inside the metal? Up or down?
Down.
Why down?
Because a positive test charge would go down.
So if I release a positive test charge within here, a positive test charge would be pushed down. So if I take a conducting plate, it has to be like copper or iron, something like that, that's a conducting electricity, and I pull it across a magnetic field, and it has to be moving. Okay? It has to be moving. If it's just sitting there, nothing happens. It has to be moving. So if it's moving, push your thumb this way, boom, it tells you that it's going to force those positive charges to the top, the negative charges are going to be to the bottom. Cool. Now, we're going to change this up a little bit. So, you all know that the force in the magnetic field equals QVB, right? You've seen this before, old school. Technically, there's like sine theta. So what this is telling you is that's going to be like the force on the positive charges. And that's what's going to tend to like push those positive charges up. In reality, they can't really do that, but it doesn't slide down. Now, here's the other thing. You're also creating an electric field. Okay? You're also creating an electric field. So, how can you calculate the force in the electric field?
Force in the electric field?
Yes.
Back it up.
Back it up.
Hey. No.
Right? True? Okay? So, old school, force in an electric field. Now, again, what's the only reason you have an electric field?
Because the electrons go down, the protons go up.
Beautiful.
Well, not really, but yeah.
So if you're not moving,
No current.
a current. So what we're going to do is we're going to set these two values equal to each other. Okay? So we're going to set X equal to QVB. Okay? So what's going to happen to the charges? Gone. Charges are gone. So you get E equals EB, right? Now, when you look at this in terms of your electric field, right? Voltage equals what? N. Right? Your what?
Why are the forces equal? Am I missing something?
Because the force from the electric field is what's caused by the magnetic field. Yeah, so like the faster you pull it, the stronger the force in the magnetic field is going to be, which is going to induce a stronger electric field.
Right.
Okay?
I hate
So,
The Three Musketeers.
the three Musketeers.
Not always good.
All right. So this is voltage. That is not velocity. Okay? Voltage. So here's what I want to do. If I look at this and I solve this for E, what do you get?
B over D.
V over D. So I'm going to put this V over D equals velocity times your magnetic field. Now, that D is the length of whatever is in that magnetic field.
Wait. Okay, yeah, I got you.
Okay?
Berg, I don't like how there's two V's in here.
Hold on.
One's big,
We'll
one's
just
small.
chill
Figure it
out.
out.
Oh, I didn't see
Hey.
that. I don't see size. What did he say? What's the quote today?
Is that you or no? Yes.
So,
Voltage or like? Yes. Okay.
what you have here, and this is what's on your equation sheet. So, to clarify why you don't have two V's, over here on the magnetism section, you have this fancy E equals believe.
Oh, I like that.
Okay? So the fancy
It's the
E
same thing.
is your electromotive force, which is your voltage.
It's the voltage that went to college, bro.
So that eliminates having like two V's. So on this bottom equation, all I did was just kind of show you where this thing comes from. Now, here's the deal. If this is going to work, and you want to create a voltage across that conducting plate, what do you have to
It's
have?
gotta be moving.
Got flow.
First off, you have to have it moving.
Velocity.
Okay? That's another reason why when I did that demo with the solenoid, if I just had that magnet in there, guess what? Nothing happens. Is there a magnetic field?
Yeah.
But it's not changing. Okay? So, what else do you have to have? You got to have a magnetic field.
Yeah.
So if I just pull a piece of metal and there's no magnetic field, nothing's going to happen.
It's just a piece of metal.
And you also have to have, obviously, some length of the metal. So, here's how this plays out. So let me doodle for a second. Give me a chance to do. Takes me back to my days as a focus.
Hey, Bert.
Oh my god.
If instead of like moving like a certain way, what if it was
I see your
like
word.
changing direction?
No.
Does it still work or no?
Force centripetal, bro.
What do you mean?
Like instead of like it moving in the magnetic
revolving
field,
around
it's just like spinning.
Like how forth?
There he is.
No, that's like linear motion.
Oh, it's gotta be like a linear thing.
What is theoretically you're talking about? What stays in the X?
Why are we drawing an airplane?
Oh my
So
god.
if you
Wait, Bert, look right there.
You would find the vertical.
Oh yeah, Gavin's still here.
That's
Bert,
actually a
look
good
right
drawing,
there.
bro.
What?
Gavin's playing.
Oh, yeah.
Oh,
I'm so happy.
I think your math is a lot.
Low. I just low key really good. Like
This
You
one,
lost.
this my one chance to kind of.
because Bergham's
Is
an
that
master
an
at this.
engine?
Physics wasn't enough for him.
Only because I sat through a lot of boring physics lectures.
Boring.
Like
Like
so if I don't turn it off, like
No.
what were the boring ones?
Oh. I took a class on quantum mechanics.
That was boring. How boring? What? That was boring.
The way the teacher taught it, it was.
How did they teach it? One of my sister's friends is majoring in
we
physics.
all
I remember the box was
They're
playing.
taking quantum mechanics and they have to think about like fourth
I'm gonna
dimension.
draw
What's
this.
that?
And then I'd be like playing.
In the fourth dimension,
I'm
guys.
just gonna do this.
So that's your math. So basically, the 8.9,
Well,
that's
culture
your
power.
power.
Would you ever
It's
teach
the-
quantum mechanics?
The
Well, I teach
volume
them
is
in
high.
this class.
Yeah, but like have like
Like,
actual
that's
guys.
has to be meters,
Focus on
so
it.
4 millimeters.
Problem is, you have to go
Like
to
it?
this class
That's a good
and
airplane.
have it make any
That's
sense.
fine.
Length,
Berkham,
remember, it's
Why?
do you
four
like my
sides.
airplane?
So it would
It's
be
a rectangle.
0.4 meters.
Does it just say? Does it just say an airplane?
Yeah, it's a rectangle with the word airplane. It's a circle. It says airplane.
Oh my
Well, now
god.
that you're
Maybe
Maybe
we just stop right
Yes,
here.
that's right. So try that.
Circles are just like
Wait, is that like meters per second? Actually, what is it?
Whatever.
You know, there's like
Okay, so here's the story.
You don't understand.
What was Jack doing, bro?
So, you have an airplane. This is why I said, hey, it gave you a chance to doodle.
Yippee.
So, the wingspan is 65 meters.
well, that's our L.
You're flying through the Earth's magnetic field. Okay? So there's your magnetic field part of it. You're flying at 260 meters per second, which is about 2/3 the speed of sound. And what's going to happen is that you're going to build up a voltage across the end of those wings. Okay? Because it's the same idea as dragging a piece of metal through a magnetic field. The magnetic field happens to be the magnetic field of the Earth. So this is why planes tend to build up charge. Because as they fly through the magnetic field of the Earth, you create a voltage across those points. The faster you're going, the bigger the wingspan is, the more voltage that you're going to build up. So this is why a lot of times, like when they go to fuel up planes, they will ground the planes first, like hook a chain up to them or something, so that you don't have that buildup of static electricity of that voltage, so that discharges before you hook the fuel source up to it, because you really don't want it to arc across that point. So I don't think they do this as much, but they used to be very fanatic about not having your cell phones out while you were putting gas in your car.
Oh, is that why?
No. So mainly because the electric field built up by the cell phone is so small. And the concern was that as you got out of the car, that sometimes you would have static electricity. And then as that static, and again, they tried this, the conditions would have to be just right, is that then if you had your cell phone and you're holding onto that and you don't touch anything else, the first thing that you touch would be your car. That would create a spark that could ignite the fuel. You don't, I mean, it would have to be the absolute most ideal conditions for that to happen.
Like, what would be the ideal condition?
Like absolutely no wind. The vapor pressure from the gasoline would have to be a very, very, very high quantity, and you would have to have a lot of potential like voltage to create a big enough spark to ignite. So basically, you couldn't.
Yeah,
My mom always
The
said
discount.
Yeah.
What's the access to the link
Alright, bro, are we done judging my photo, bro?
You're like
I like how it's brown, dude. It's not brown. It is. There's just some little spots here and there.
You know, I still
Dude, little spots. Well, look, okay, that's just the little spots everywhere, bro.
Your
You don't
router
get it.
checks
Yeah.
all your
Yes, I do.
like everything that leaves it checks.
Did they
So your service provider knows everything that's going on.
So you get AT&T.
Again, I put powder every single day.
No, it's
Like, I cleaned it last night, but it's like powders that are like this much powder.
You know what?
And
You're
like,
gonna have to ask
I
me,
don't
bro.
mix it well sometimes, it just takes
So-
the size.
But you're a good boy. You didn't.
I only know this because they went into my room and they're like, we checked it.
Just
I'm
don't
proud
smell,
of
you
you.
know.
And then my dad
You should see my smoothie bowl.
Where's my?
I'm always worried. I have it with me, but I'm not gonna show it to you.
Okay. So let me kind of show you what I'm trying to draw. So this is kind of similar to what we did yesterday with the rail gun, right? So I've got a wire that's laying flat. So imagine this is the wire. Imagine I've got a magnet underneath that's producing a magnetic field that's going in. So you would have something like this. So I've got this loop wire. I've got a magnet that's underneath it, okay? And the magnetic field is going into this. Now, here's the tricky part. Then I'm going to pull a metal rod across it, okay? So visualize this. The magnetic field is going into this area. I've got a magnet that's creating that magnetic field, and then I'm going to pull this across it. So I'm going to pull it this way. So it sounds odd, but here's the best way to visualize this, especially for those of you that are in band, choir, performing arts. Imagine this is the curtain and this is the stage. So if you pull this in this direction, what are you going to see more of?
Stage.
X's or dots? So if you pull, imagine you can't see this over here. So as you pull this in this direction, then Mr. Future Band Director, you pull this
I
direction.
can't see because you're.
What are the people going to see?
The X's.
More,
So what's with
more X's, or are they going to see more dots? They're going to see more X's. So as I pull this, they're going to see more X's. Mother Nature is looking at this going, the audience going, dude, I'm seeing more X's.
Ew.
Yeah, that's definitely what they
So
said.
what's Mother Nature going to want to do?
Oh.
Mother Nature in this region wants
Hey,
to make
Nathan.
more
You're shaking my
O's.
Oh.
Now, obviously, if I don't pull the wire, what's going to happen?
No changing.
Nothing, because nothing is changing.
No induced current.
Oh, no induced current. So,
All I asked was
here's
a
the
question.
question. Which direction is the induced current in the wire to make more O's on this side?
North.
Up.
What?
Up.
Yeah, north.
Bro, Nathan, shut
No,
up.
So, if I induce a current going up around this wire, I'm going to create a second magnetic field, which is going to be pointing upward. So I'm going to have a permanent magnetic field, but then I'm going to induce a magnetic field to oppose the fact that I'm seeing more X's. Okay?
Oh.
Right? So I need to make more O's because I'm seeing more X's. So if I send my current up this way, I wrap my hand like this on this side, which is seeing more X's, I'm going to make more O's. So the current
This unit really is autism, bro.
is going to be going in this direction. Okay? So the current going around like this is going to be going like this. Now, here's the tricky part.
No.
Oh, here's the tricky part.
Wait, isn't it?
Ash!
Oh.
At this point, we have a current going this way. We have a current going this way. Go with this. Current going up. The external magnetic field that I'm pulling it through is going in which direction? Inward.
Oh yeah.
So the current now is going up. The magnetic field that I'm pulling it through is going in. What's the direction of the force?
Left.
Left. Which is why I have to apply a force to the right to overcome the force from moving it through a magnetic field.
Can we go back 10 seconds?
Can I go back to
It's not a
what?
YouTube video.
Please, just I need the left. We're pulling that way. Why is it left?
Okay. So
We're just grabbing.
let me back up 2 steps. Okay. Here's the curtain that I'm opening up. Mother Nature is in the audience. Mother Nature is looking at this and going, I'm seeing more X's
Yeah.
because I'm pulling the curtain away. You're looking on this side. Okay? You're pulling this. You're seeing more X's. Mother Nature goes, boom! Nurse! Bring on the O's!
Yep.
Okay?
Yep.
So Mother Nature goes to this edge of the curtain that's being pulled back. Mother Nature is going to, I'll counter you. So Mother Nature induces the current this way. That creates O's over here to balance out the fact that she's seeing more X's. Okay? Go with this. So I've got a current going like this. Now I'm going to, hold on. Now I'm going to use the right hand rule again. Now that I know the current is going in this direction, so I put my thumb up. The magnetic field that I'm pulling it through here is going into the page. So I send this up. My fingers point this way. These point to the left. So when I pull it, the force from pulling it is balancing out that force that's created by the magnetic field.
Oh, okay.
Okay?
Oh.
That's what Mother's saying. You know when we've been only talking about induced current?
I didn't know we were the ones creating current. Like by the force.
Because if I don't hold this, what's going to happen?
Nothing.
Because I'm not going to change what Mother Nature
I just had a
sees.
eureka moment.
So if I don't hold this, nothing happens.
Jack, what does induced color mean? Induced labor.
What?
I'm just telling you.
No,
These are big words, bro.
Induced, ask ChatGPT.
No labor.
Labor?
What, Big Mike?
So those, oh,
Egg coma.
that's where the X's were, but then we moved the X. Because
No,
the
you just don't know what that
O's.
means.
There you just add. Oh.
Dude, you're going to overcomplicate this. Go.
Wasn't how we coming across?
You can't change the number of X's
I'm not good.
because that's created by a magnetic field.
Yeah.
You can't change the number.
Okay? So what Mother Nature sees is the fact that you're seeing more X's. So as you pull the curtain back, Mother Nature is going to see more and more X's. And so Mother Nature goes, hey, I like symmetry, so I want to see O's to balance out the X's.
Wait, I thought this whole time. Wait, are O's not the absence of X?
What?
Bro, this is not philosophy, bro.
What? What did you really
The
think?
heart does not go fonder
Dark
with
is the absence
distance.
of light. Because like we have.
Does mother know you will have a drag? Get off!
What did you
Iron Man. This
Hey,
stuff-
Berkey looks a little angry.
Huh?
You look a little angry.
This is a lie.
Really? I'm almost 60 years old, and at this point I'm questioning my life choices.
You just started
The
questioning.
Oh, you're gonna curse this way.
Just watch the lecture, dude.
Just watch the lecture. Hey, if only you watched the video from yesterday. Yeah.
Oh wait, what's the code word?
The code word today.
No, we're like, do they know?
What's the inner?
Yeah, what's
I
the
do.
code word for
What is
today?
it?
What is the code word? What's your
No code word. It's a joke.
No.
Ask somebody.
Oh, today there just is no code word.
No code word, right? You ask.
So
hey,
today
what's
is
the
the
code
absence of the code word.
Wait,
No!
I think it's too early to do that.
No, I think it should be induced. The code word for the day.
No, can we
is
do a
induced.
phrase?
Yeah,
Can
what
we do a
about
phrase?
What about what?
Drapes.
Drapes. I
No, can we do a phrase?
Okay.
Mother, no, you
Code word for today is drapes.
Just watch the video.
Just watch the
This was
video.
from like 5 days. This
What?
was from the start of Math.
What? Dude.
So, if you roll back to the start of Math.
If you roll back,
Behind is the fourth
Michael, what happened to
dimension.
magnetism?
I'll go over this later. I don't have time right now. Okay.
Hey, Kayla just asked what a magnet is.
Huh?
Kayla just asked what a magnet is.
is?
I mean, just
There's
go
a
in.
bunch of magnets in
That was
that.
I don't like
A
it.
magnet?
Well, you're
Yeah, it's a joke.
Okay, X means it's going into the paper. Like X marks the spot, like that's where you dig.
Like R.
Bird. I miss bird.
Oh my god.
Yeah.
Oh, I understand it now.
I love circuitry.
I understand now.
Oh,
Oh no.
Whoa.
Making weird
No, just stay with me.
Where the E
Stay with me now.
is.
Let him go now.
Bullet is E.
He's eating
Wait,
that.
relax.
Hey, Michael, what did you say about O's again?
The absence of
X
X.
is.
Wait,
Wait, whoa. Relax.
Which is voltage. Okay.
Where are the
Oh,
numbers?
we're on
Voltage. Okay.
There it is.
Why are we trying to predict it though?
I'm not trying to predict it.
So I'm not
Why are you putting B in the middle?
This is how you make your equation.
Oh wait, I see.
I guess, bro.
Yeah, you just
Oh,
put it down.
wait.
Believe.
If that's what you want to say, I'll just believe it. Like,
guess, but like.
I don't really know about that.
Where are they all individually
Oh
squared?
my
Can
god.
Can we?
Where are they
Why
all
are they all
individually
squared?
Hold on, Bird. One at a time. What is that?
Yo, Red.
Oh no, we're okay.
That's an
Can you
F.
cancel out that R? Have one?
Berg, where are they all?
That's what he just did.
Go John McGinn.
So, let me explain where I end up.
Wait.
Oh, I
No,
see.
Big Mike, just let him explain.
Big Mike, put the hand down.
I was looking at it.
Don't do it, Big Mike.
What?
That last thing.
Shut it.
What can you possibly be confused about?
That's
one last
let me
thing.
explain it.
Shut up. Shut it or.
Okay? Just let me explain it.
Wait, this is for my.
So,
Yeah.
if you go way back to circuits and you burr it up, right? True? If you solve for current, you get voltage over resistance. True. But we just said that E, the electromotive force, is the same thing as voltage. Same thing, just a different symbol. But then we also said that that voltage equals believe. Okay? Makes sense.
Yeah, believer.
So, all I did was put that in for I.
Okay.
But in terms of power, power can equal I squared R.
Ooh.
So if I put believe over R in for I get B squared, L squared, V squared over R squared.
Why are they all
Forgot an
equal
R,
squared?
Because it's
You lose one of your I equals
because you're squaring the whole thing.
Ryan, you are not.
So why isn't it BLV squared?
brother.
That is BLV squared.
But you just squared everything.
Fine. If the whole
It's the
thing
same
was
thing.
squared, how would you cancel the R?
You lose one of your R's.
No, it would still work.
Okay?
4 times
What?
3 is
4 squared is what?
16.
16. So that's like 16 times 9.
Yeah.
Right?
150.
Okay? That I could also write that as, in this case, 12 squared. I'm going to get the exact same thing.
Oh! Break is so smart.
So, I'm going to cancel out one of the R's.
I really don't like.
So, if depending upon what you're given, in terms of the power that it's going to take, you could use B squared, L squared, V squared over R. Okay? So, as the resistance becomes smaller,
Power goes up.
power goes up. Okay. And the faster you pull it, the more power that there is.
Ooh.
Okay.
How fast is
We
it?
got a book.
Oh,
Maybe we watch more videos.
I quit.
Hey, ain't we graduating this year?
Hey, I believe in it like that. What does it mean?
They might give no pushback.
I believe it. No, I got crazy pushback.
No, you don't.
Yeah, I got
Hey, it's because you haven't seen it.
What are the O's?
He's clutching till the
Hey,
end
what are
of
the
the
O's?
year.
Praise the Lord.
Oh my god, Burkett, like you're the best.
There's a reason why there's not that many
That's-
questions.
This is the best
There's a
ever.
reason. There's a reason.
Bart, we love you, Bart.
Now.
25 plus
And this is for
How much work is left?
Open up this to chapter 25, and let me show you some on question number 3. No, it's not a long assignment
Are you
at all.
gonna share with all of us?
Can you screen share,
That
Bart?
scared me.
Can you just bring your book?
No.
You didn't tell us we are.
What?
No, you know what's 20 pounds is our chem book.
Oh, Troy!
Our chem book is heavier than our physics book. Yeah.
I don't carry out.
He doesn't carry 8. Alright.
It's okay. You got it.
Babe, I can only carry one when I use chem today.
Chapter
Physics. I know, but I had an actual book assignment.
What page, Bert?
This is page
Physics.
832.
You're just race rating me, and I don't stand for it.
You're just getting rage baited, so.
If I just outline
I'm just gonna say it because I don't stand for this.
That's so funny.
Okay,
You should.
so on
He's
question
hysterically
number
laughing.
3, you have a series of diagrams.
It's actually funny.
And it says, for each determine if the induced current is clockwise, counterclockwise, or 0. So, here's 3A, because I want to make sure everybody's cool with how this is going to play out.
Yeah, it's 3.
On 3A, you are pulling this wire like this. So, here's,
We're gonna need to make
visualize this. Here's the loop. Here's this bar that goes across it. I want to pull it this way. Here's the curtain going down like this. You're Mother Nature, you're watching it. What are you going to see more of?
Exit. I'm so stuck on that. It was a 50-50 shot.
You pull it this way. What are because she's seeing more. Oh! So,
The current's going to the left.
It wants to go plus Y.
you need to make X's. So what's the direction of the current?
Clockwise.
Clockwise or counterclockwise?
How?
Wait, what?
Wait, how?
Left on the bottom, right on the top.
Oh, you're talking about the circle.
Whoa, don't make fun of him. I'm confused here too. What?
I get it.
You see how
Everyone needs their this is
one like
floating
this.
wire. Hey, this is what's being pulled. Okay? So as this gets pulled, you need to make X's on that side.
Thank you for
So as
doing
this
that.
gets pulled down, this is going, you need to make more X's. So the current's going to go in this direction.
Oh, yeah.
So the current's going to go around like that.
Oh.
Oh, actually, X's.
Hey, you're in the camera. You're in the camera.
Cool with this one.
It goes like that.
Because then it
Now.
continues going in that direction.
Alright.
If you look at C,
What is D, bro?
for those of you that have C, what's going to be the current? If you look on this diagram,
Nothing.
it's a wire with just a bar.
It's not moving.
It is moving.
It is moving. Oh, I didn't know that.
It is moving.
I can't see
Nothing.
it.
Nothing.
Guess.
Nothing still
It's in
happening.
the same
Oh, wait,
way.
yeah.
parallel
Nothing.
Are you
Zero.
changing the X's or O's?
No.
So if you don't change the X's or O's,
Nothing.
nothing.
Oh,
Now, but what would happen on this first one if I pushed it up?
What?
Instead of pulling
Opposite.
it down, what if I pushed it up?
Oh, counterclockwise.
What's Mother Nature going to see less of?
Oh.
So she's going to make
X's.
She's going to make more O's because she's seeing less O's.
Since there's more
If this gets pushed up in this region, she's going to see less O's. Mother Nature's going, oh, woe is me. I'm not seeing as many O's, so she's going to make more O's. So the current would be going in the opposite direction. Counterclockwise.
So,
Okay, good luck with that one.
Wait, can you scroll up to the assignment?
There was a reason why she was coming.
I figured out what X is.
Oh, my jaw.
Too many homework.
Get mine.
My jaw hurts.
I know, wait, let's see what mine is.
Right? When we first started this, I get so right?
Oh, we did a 30.
You look so happy.
For real. Oh.